Okay, we're back to C++ boot camp. I'm not starting from the beginning. I'm going to pick up where I left off, but I'll review a little bit because it's been a week since the time we got there. So for those of you who already have a background in basic C, this is going to be boring, but it might take you down memory lane, maybe. Might remember a few things. As I promised, we're going to spend a little bit more time here today. This might be the end of it, though. Next week we'll be starting in with C++, object-oriented design and stuff like that. Because I think I got through about half of this last time. So it's usually sometimes 2, sometimes 3 class sessions. Depends on how fast I go through it. And today's also your opportunity to ask questions as well. If there's something you want to know more about, something I went over too quickly, something you can't remember. This is with the assumption that you've got some programming experience in maybe Java, or maybe C, who knows, but maybe it's been a while. But before we talk about the object-oriented components of it, it's good to review, actually, some basic C stuff. So feel free to ask questions today. This is your opportunity to refresh your memory. So last time we talked about the skeleton program, talked about the include with the iostream.h, talked about the void main. Void main is actually a function. So in C, everything starts out with a function. Kind of different than Java. Java's everything's a class, everything's an object. But in C, we've got a function here, void main. Void means it doesn't have a return type. And as I mentioned before, you can go ahead and memorize this because this is what you're going to be writing most of your C programs with. In fact, this applies to C++ as well. We always have a function that starts out called main. Talked about commenting code with the 2 backslashes here, or forward slashes, and then this convention here with a forward slash and an asterisk. 2 kind of conventions for documenting. Documenting maybe refers to putting comments in your code. We looked at the cin and the cout. Cout prints stuff to the screen. Cin takes stuff in from the command prompt. So you use cout, pronounced C-out, not cout. Sin and cout. No, cin and cout is a better way of doing it. And then here's some examples of how we use the cout, and then we have the directional arrows that say, put to the screen. This is a sample string. Put to the screen, this variable. So we can use it in combination of strings and variables, and we can string them together. If you're a C programmer, this is new, because this is part of iostream.h, which is part of C++. If you're a C programmer, you might be familiar with printf and scanf. That's part of stdio. So it's the same concept, used differently. This is the object-oriented version of the printf and the scanf, essentially, or the equivalents, I should say. Getting input from the user using cin. So here we have integer myint, and then we have cin, which means bring in myint, and copy whatever the user types on the keyboard, and basically store it in myint. And as I mentioned before, when the arrows are going this way, it's bringing it in. Arrows are going that way. If you think of one of those blowhorns, those loudspeaker things you blow into, or yell into. Cout, yelling out, essentially. So it's like a big old horn, if you want to think of it that way. Most students have problems with the directions of the arrows. Most people remember that there's 2 of them, but you'll accidentally switch the arrows when you start using these functions, or method calls, actually. Here's some more examples of the cin. Noticing that the cin is going this way. It's bringing it inside to my integer in this particular example. We can chain the string operations together. So we have cout, first item, second item, third out. There's no limit, actually. There's no minimum or maximum. Actually, you could just put cout and end line. That would just put a line return if you wanted to put a space in there. We have the special sequence characters. I actually kind of skipped through this because we don't use them very much. This comes back from the printf kind of statement where we could put escape sequences in there to put tabs, new lines, and the /n. This is the one most people used with printf. To say, give me a line return after you print out this piece of information. But those can also be used with the cin cout. Same concepts apply with the printf. And we looked at the first program of a hello world program. And all it did was print out the words hello world. I actually showed you this in dev C++. If this is the first time you've attended this course, and because I know it's right in the beginning, and if you're looking for a compiler, you don't have one, you can come see me after class and I can turn you on to a compiler I call dev. Actually, I don't call it. It's called dev C++. It's by Bloodshed. It's actually not a bad compiler. It reminds me of the old C compilers of before Microsoft got carried away with .NET, like the old 6.0 compiler. So we looked at Hello World already last time, and we also looked at some of the syntax rules according to what standard C, and also applies to C++ with the semicolon at the end of each statement. And then we have the opening and closing brackets. They go at the beginning and the closing of blocks. Blocks would be, for example, here, this function, and I'm going to talk a little bit more about functions today, where we have an opening and a closing bracket that's associated with the function. And the function is main, called main. We talked a little bit about, here it is here actually, the beginning and the ending in green, and the semicolon here after each statement. We don't actually put this at the end of the function. It's just after each statement because it's basically showing us blocks. We looked at compiling programs a little bit as well. We also looking at knowing when to compile. The overview of variables. I also covered this last time. The different variable types, the concept of declaring and initializing variables. When we declare a variable, we give it a data type, and then we follow it by a name. So we can say integer I, so the data type would be int, the variable name would be I. Same thing in Java, actually. In fact, Java's got the same rules in terms of declaration and initialization. We can initialize it in the same statement. We can say integer I is equal to 1, or integer I is equal to 0. And then we've accomplished both in the same line of text, line of code, where we've declared it and we've also initialized it. I talked a little bit last time about primitive and complex data types in terms of what they are by definition. Some primitive type examples were the short, the integer, the long, and the concept of these all being integers, and the fact that the short takes up a very small amount of space, memory, and that the integer takes up the average and the long takes up a little bit more. And in terms of what we're trying to accomplish in the very old days of programming, we had limited memory resources available to us, so what we wanted to do is conserve it. So we declared variables of a particular data type, so we would reserve the amount of space needed to store a value that was associated with the variable. If the variable was an integer and it was like a number between 1 and 10 or something, we would know there's only a 2-digit number. We would probably use a short for that for very small numbers. If we didn't know, we'd probably just use an integer on the average. Or if we thought we were going to store a really huge one, we would probably use a long for the number. It basically gives us enough room to store the data that we're looking for. Because what we're looking at here is called named variables or named memory locations. When I talk about pointers later on in the course, you'll see the difference between an unnamed pointer in terms of a memory address versus putting a label on the memory address calling it integer I. I would be the label that you're putting on it. So when you refer to I, that space, you call it I, which is why it's called named. We also looked at the primitive types of float, a double, for currency, for decimal precision, character, Boolean, and the trues or falses, or ons or offs. And the concept of declaring a variable, what exactly happens when you declare the variable, whether you use it or not, the compiler goes out, finds a memory space, slaps a label on it. In this particular example, we have byte age, float GPA, string name, and letter grade character as a character type. And then the amount of space that's reserved is particular about, given the data type that you've specified, it's going to basically give you the amount of space associated with that. And the concept of the data type, actually going back to this concept, not only gives us the amount of space, but it also gives us the allowable range of values. And it also gives us the particular operations that are proper for that particular type. As an example, if you said character letter grade, and you typed letter grade plus other grade, and they were both characters, you'd in some languages you'd get a concatenation. Where you'd have if letter grade was C and the other one was C, you'd have CC. In other programming languages, you would get an error like C. This is you can't add it together. Unless they're numbers. Numbers we can add together, we can subtract. Or actually, I think in C you get the ASCII equivalents to C as a number added to the ASCII equivalents to the other character, and you get some odd number that comes out of it. Because the plus and minus operators are only good on numeric values. They don't work with concatenation. So there's some interesting things that little side effects of operations. So our data types give us our set of operations that are allowed as well per character, or excuse me, per type, per primitive type. We can also find the size of something by using a size of, and this is really a method call, but we're using it in terms of here, we're calling a function size of, and we're passing the function my integer, and we're printing it out to the screen. We'll see in C++ everything is in terms of an object, and we have methods that we run on the objects. Very similar to Java, actually, when we start getting into it. At this point, we're sort of looking at C++ without looking at the object-oriented components of it, which makes it kind of interesting because we have both functions and methods that we're using. We looked at the naming conventions for variables and the fact that you can't use a reserve word, and no one's going to go out there and memorize all these reserve words, hopefully. But these are some special words that you can't use as variable names. Obviously, case, catch, catch, class, constant, those are all kind of reserve words. We also looked at legal variable names, and that they can't start out with what's legal and what's not legal. Can't be a reserve word, can't start with a number, which is kind of interesting. Can't contain special characters. And the only exception, such as the underscore or the dollar sign. That's why you see a lot of variable names with dollar signs and underscores, because they're legal. You can't start out with like an @ symbol or something. Although some other languages use this. A lot of scripting languages use the @ symbol actually for arrays and stuff like that. But here we have byte. This is legal. Using the dollar sign, the underscore is legal. This isn't. It's a reserve word. This isn't because of the symbol here. This isn't because we have spaces, and we're also using reserve words. So we've got a couple of different problems with that one. So. Literal values, looking at the values that are constant. As an example, is a literal, string literal, hello world, whole number literal, 17 decimal, let's say pi, the definition of pi, and a character literal v, maybe for valid or invalid if you're sending a bit on something. We also looked at the concept of initializing variables. In fact, the concept of it being down here as the examples go. We have an equal sign, and this is where we run into problems when we start looking at the comparison operator. If you remember, it's 2 equals. So we say if this number is equal to this number, if we go equal, we're actually going to assign. So we actually assign one value to the other value, which causes kind of an interesting side effect. And it's always resolves to true, but I'll talk about that in a few minutes. So an example, integer age is equal to 15, as an example. So we have 2 stages. We can declare and initialize, or we could put them together and say character grade. Actually, we didn't put it together here. No, we just assign one to another, looks like. But we can initialize in two sentences or one if we want to. We can combine the statements together. And here's my example as to why size actually matters in terms of the variables. And depending upon the data type that you declare for a variable, in C++, we have this thing called type casting, where we take one type and turn it into another type, because it's a strongly typed language, and what ends up happening is we find a need to add a double with a float, add an integer with a double, and we end up having to convert one to another type so the types match, because it requires that you have to add like types, and you have to work with like items. So there's a lot of casting that goes on in which we have to take, and let's say take a small one. We could put a small item into a big space, it fits just fine, but if we put a long item into a short space, we have problems. We have lost precision. So it actually makes the language a little bit unreliable if you think about it, especially if you're working with dollar values and you truncate it. It could cause some interesting, and it's not going to round, it's going to cause some interesting errors for you. Looked at operators in terms of the classic, the addition, a subtraction, a multiplication, and the order of precedence, which follows basic algebra standard math rules. You know, everything inside working outside, multiplication, division, then subtraction and addition after that. And using the brackets. You can actually use the brackets anywhere you want, essentially. You're never going to get an error message by using too many brackets. Bracket at 12 deep. Never have a problem with it. And here's that word typecasting that I talked about in terms of the formal definition of it. It occurs when you put something larger into something smaller. You've typecast it. And it basically just means that you're converting one type to another type. You could possibly lose precision or value. Typecasting actually doesn't mean you're going from larger to smaller. You could go from smaller to larger, and that would be the same term that would be used for that. And the example on the bottom here, we have a long, my long is equal to 17. Short, and we've typecasted it. We said, my long, call it a short. Convert it to a short and add it to my shorts. So we took a long number, we turned it into a short number. We added it to a short variable. So we're squeezing my long into my short. Believe it or not, this happens a lot in C or C++ in everyday kind of usage, which is why I'm mentioning it in this boot camp lectures, because you never know. I mean, it always comes up for some strange reason. All right, we looked at, we got this far. I think we also looked at conditionals and Boolean expressions as well in terms of the flow control of the program. So what we're looking at is flow control. And the Boolean, that's something that resolves to either true or false, or 1 or 0. And you get Boolean several ways, simple or complex, by one single Boolean expression or multiple used together. And they're used to make decisions to change the program behavior. We'll see it with a case switch. We'll see it with if, else, then, else's. And in fact, we covered the if, else's last time. We looked at the relational operators. By definition, these relational operators are greater than, less than, and here's where that comparison or equals operator comes into play. Oftentimes I see experienced people just go equals. If this one equals this one and leave out, just put one of the equals in there. And what they've done is an assignment, which always resolves to true, so the structure always comes true. And you never get an error message, but you always wonder, why did that value change and what is going on with this program? Because you did an assignment rather than a comparison operator. So the operators, knowing the operators and knowing how to use them is important in terms of making your logic work correctly, in terms of your program statements. Notice that all of these return us a true or a false, which is kind of an interesting thing. A lot of even experienced people don't actually even realize, but every one of our conditional operators, every one of our conditional statements, all of it is either true or false. That's how we're controlling the logic, if you think about it. So we have some literal expressions. Is 5 larger than 3? Well, that would be true. Is 6 not equal to 6? So that would be false. So you have to go think back at I guess this is algebra or something, a variant of it. Actually, it kind of looks like discrete mathematics, actually. What kind of gives you the operators? We have variable examples here with the integer number 1 is equal to 5, short, number 2 is equal to 7, and then doing a Boolean. So we have result is equal to number 2 larger than number 1. The result's now true because we're doing an equals. Every time you do an assignment, you always get an equals, actually, which is kind of interesting. Kind of a side effect that occurs. I think we got this far as well. We looked at and or operators, the two ampersands together for an and, two parallel lines here, perpendicular lines, excuse me, for an operator. And doing the comparisons themselves again, using the brackets to nest the comparisons. This is where you get most of the difficulties when you try to put something together. Like if the port failed and the user is authenticated, then try the port again. Otherwise, try something else again, or do this or do that. So you can basically look at something and determine how you should proceed. So let's do something with this. So we looked at the if statement. I've got this far as well. Using the if statement, we can decide whether or not we're going to execute some of the code or all of the code, or what are we going to do. Has the format if, and then this is where I'm reiterating the point where we have a Boolean value. That's why I can sometimes see if, and then in here, the more experienced programmers will put a variable, because a variable has a value, and the variable might be a Boolean, might be true or false. And then you can do your calculations somewhere else, actually. So you'll see, if I, and I is false, then we know not to go. If it equates to true, then the if statement actually executes. If not, it doesn't. So we can put an expression in there as well, if I is less than 5 or something. And then here we got our example here. I went through this already in terms of the output. So we have if start is smaller than n, which it is, print out a, and we end We ended the if with the closing brackets, and then we also printed out B. So we got A and B printed to the screen. And we also looked at this example where we said if start is larger than end, print out A, then or print out B, and we have B because, you know, obviously start is not larger than end. It's smaller, excuse me. And then we looked at the else statement as well last time. This is all a review of what I went over. If you've missed some of this or some of this isn't clear, look at the video from last week. If has a counterpart, it's else. So if clause didn't execute, the else clause will, and we can have multiple else's. So we have if some expression, nope, else, else, forever. This makes it actually kind of complicated because we have if, else, and we can nest these as well. So we can have if and else's and everything in between all of the ifs, else, and this makes it really spaghetti code sometimes. So here we have another else here where we've put an else in here, so we're going to get either A or B printing to the screen. In this case, we're going to get B because start is not larger than end. So A is not going to print, but B is. And then we've switched it around now so that end is smaller than, start is smaller than end. We switched this little arrow here in this next slide so that we have A but not B. Once it hits true, then it stops. We don't get the else. So one of the options is going to occur, and only one of the options will occur. So if you have multiple else ifs, it doesn't matter. When it finds something that is true, it stops and it prints it to the screen. And so in terms of our else if, something's rolling all over the place. Tons of noise. We have if start is smaller than middle, print out A. Sounds like an earthquake, doesn't it? Else if start is smaller than end, print out B. So we've done an else if instead of starting out with an if again. We actually don't need to. We don't even have to use the else if. If we don't use the else if, we'll get multiple things nested that will print out to the screen. The else if says one or the other. So the else if is actually more effective in terms of getting the desired response. But a lot of people don't like to use it. They'll just nest an if in there, and then you end up with multiple ifs happening because each if sequence is going to have a true or a false associated with it. So if you want multiple, you nest the ifs, and if not, you do the else ifs, and only one of them happens. We also looked at the else if along with the else for the catch-all. So if all else fails, do this, which is what we've got on the bottom to print out the number C, the character C, because the first and the second ifs are going to fail in this particular example. We also looked at the switch statement, and this is what causes, again, brand new people a little bit of problems. We can simplify the else if, make our life easier, and say, let's put in a case switch. And I like to call it a case switch, even though it's really a switch case, because we're switching, and we're using a character or a number. It could be an integer or it could be a character, a single value, where we've got case, is it this value, case, is it that value, is it this value? And depending upon which value it actually prints out, we get something that prints out to the screen. Here's an example here where we have switch my integer. My integer is equal to 1, but we're switching my integer, so if it's 1, it should print out A. But unfortunately, the side effect is that we have multiple select operators that are going on here. So it finds it, prints it out, but then it continues and prints out everything else after that. So if my integer was 2, it would print out B and C. So we put a break in there, and a break stops it from continuing. Once it finds a match, it starts, and then it starts printing everything out to the screen, which doesn't make any sense to brand new people for some reason. I don't know why. Okay, so here we just put the break statement in, and we've stopped. We've stopped essentially. Okay, I found A, print out A. Okay, break. Break can actually be used in any construct you want. It could be used in a loop. It could be used in a conditional expression. It's used outside of the switch case scenario. It's just a key word that's being used. Don't type in exit. Exit will actually exit the program. Will terminate the execution of the program. Break will just break out of its current sequence and return to the next line of code that called it. We also have the default keyword that can be used with the switch case, and the default shows up at the end, meaning that if none of these actually worked, then use the default. And the default's going to be something generic that's going to happen. And here is our example where we've changed the value of my integer to 5. We have 1, 2, well, no matches. Default, print out C. So C is going to be printed to the screen by default. A lot of people, for some reason, don't like to use the default down here either. You know, they go around all these different ways of doing something when all you have to do is put a default down there. Put a value in it, like null or something. You know, put some default value to that variable or something, and then you don't have to worry about it. Okay, I think we also got this far, perhaps, or maybe this is where we stopped. This could have been where we stopped, so I'll slow down a little bit. Next thing to look at is the concept of iteration or looping. And so one thing that computers do is repeat commands over and over again. So we have pretest and post-test loops. We have loops that go continuously or endlessly on purpose. And we have loops that go for a certain number of times. And like in any other programming language, they're almost identical to Java, actually. And in fact, I think they are 100% identical in terms of the logic and also in the structure. So we have loops here. We have 3 kinds. We have the for, the while, and the do while. And the criteria for the loops usually have some initial condition, maybe a starting count or maybe a beginning of a certain particular state. So you have to test and then continue. And most programs progress towards finishing, hopefully, and they break out of the loop. If you have an endless loop program, what ends up happening is, especially if you're doing assignment variables or something, declaring and assigning variables or something, you probably will run out of memory before your program actually ends, naturally. So bad children are told to write sentences on the board. So you could say, I won't pour Clorox in the fish tank. So if you had this problem where you had to write the sentence on the board 50 times, are you really going to write it 50 times? No, if you're a computer science student, you're going to write a little loop. Yeah, and the loop's going to do it for you. So you have to write the sentence either a certain number of times or until the teacher's happy, or as many times as you can during a particular break. Which is kind of like how network programs actually is. You know, go search for something, go update something, go log something. So going on, the exact number of times the for loop is a fantastic situation, and believe it or not, even experienced people, especially Java people, have a problem for some strange reason getting the format down. So if you had problems with it in the past, here's your opportunity to learn it. The format's quite simple. There's 3 components to it. In C++, you can actually declare and initialize your starting variable inside of the for loop structure. Some variants of this don't actually allow you to do that. In fact, older dialects of C had you go integer I, and then in I is equal to 1. So you couldn't do integer I is equal to 1 right here. You actually had to declare ahead of time and then initialize. But you've got to initialize a starting value of a counter variable, test a condition, and then increment the counter variable. So everything is that's going to be repeated goes in between the statements. So initialization is where the counter is given as starting value. You test it, whether or not you're going to continue, and then you increment negatively or positively until after all the statements have been executed. So here's an example. 1,000 sentences, no problem. We can do 1,000 sentences quite easily. And this is really the standard way of doing it. I would say do it outside of the loop. Say integer counter, and then say counter is equal to 1. Depending upon your compiler, you probably could do integer counter equals 1, right there in the loop. But I don't believe, I think Java allows you to do it as well. There are some languages that don't, actually. So you usually see it like this, only because, it's the safety way of doing it. So if the counter is less than or equal to 1,000, counter plus plus, here's the interesting part, where most people will try to put a semicolon at the end of counter plus plus. It's not the end of the statement. The end of the statement is actually at the end of the bracket. So if you remember, counter is equal to 1, you're initializing the variable, put a semicolon in. This is a separate statement. You can actually write this on 3 different lines, actually. You don't have to put this all together. It's commonly written like this for readability, actually. Counter is less than or equal to 1,000, you have to put a semicolon in because that's a new statement. Third statement, counter plus plus, meaning go for the counter. But we're not done yet. Counter actually doesn't get done until the end of the statements. So we're remembering that counter plus plus is the same as counter is equal to counter plus 1, if you're not familiar with it. If you want it to be numbered, you can actually put the number in the particular loop and use the counter variable. There's no restriction on what you do with that counter variable. So integer counter is equal to 1, counter is less than or equal to 1000, counter plus plus. So we're going to see out counter. Yeah, which is going to be, in our particular case, 1. I will not pour 2. I will not pour 3. I will not pour, I'm not going to go up to 1000, but that's essentially the point. Eventually we're going to get there to the end. So counter is equal to 1. This is how it essentially works. I'll show you the iteration through this particular loop. And then after we have counter is equal to 1, whoops. Then we goes counter less than or equal to 1000, true. If it's true, it's going to continue. Believe it or not, this is still a Boolean. The entire expression is, everything is controlled. All flow control is controlled by Booleans, believe it or not, in language. Same thing true for Java, actually. So output is going to be 1. I will not pour fish tank water in the Clorox in the fish tank. So we have counter plus plus. Incremented counter, now we have 2. And now it's true. It's still less than or equal to 1000, so it's going to print out 2. And then it's going to go through again. 3. This does not go to 1000, so don't worry about that. 3. Let's bump ahead. 4. When will it end? It will never end. It'll go on forever. No. Actually, it'll end when you have interesting later around when you have 1000. So you have 999 is still less than or equal to. Yeah, it's still less than. So we got 999, but now we have 1000. So it's true for the last time. It'll actually go from 1 to 1000 because we've got this counter initialized at 1, which is interesting because it ends up people get 1 extra. People like to start things with 0. If you want 1000 and you start with 0, you're going to get 1001 because you're going to get 1 iteration for each number. So this is what usually ends up happening in terms of troubleshooting. People go, how come the loop's going 1 extra time? How come and you're using the loop to populate an array? And that is actually when it starts getting tricky because you only have certain array values and you're writing past the array values because you've gone too far. You've started your counter out the wrong way. So either you get in the practice of starting with 0, which is actually more popular, or 1. But people will say, if I want 1000, I don't want to go from 0 to 999. It's easier to go from 1 to 1000, theoretically. Alright, so when it hits 1000, it's going to go through because 1000 is going to be equal to 1000. It's going to be true. But on 1001, it's going to come back and say false. So then it's going to jump to the end of the closing bracket and your loop is going to end, essentially. So your final output will go through 1000, this particular example. While loop runs a little bit different. This is why we see while I is true. And out there, I is getting changed. And hopefully maybe I is getting changed inside of the loop. So while something is true, while something is false, you can check for both, actually. So it's good for when you don't know how many times you want to repeat it. The teacher says, write until I'm happy. And has a format while, some Boolean expression. Do some stuff, repeated it over and over again. So Boolean is teacher happy is equal to false. So teacher's not happy. So while not teacher happy, while true, because if we have teacher happy true and we say not, then it's going to go false. So the logic with this exclamation point for the brand new people to this means we're doing the opposite. So teacher happy is false. So while true, because remember, always it equates to true. We never get an expression that runs with a false. Then line number is equal to 1. This is going to be a little counter in here. Now we got our own counter inside. So we're going to print out line number, I will not, right on the pour Clorox in the fish tank or something like that. And then we have a teacher happy is going to be equal to, and then we're going to do a function call here to attitude function to figure out what if the attitude's changed or not. If the attitude's changed, then teacher happy is going to be true eventually, hopefully. And then not true is going to be false, and then the loop's going to end, hopefully. So we're going to rewrite it using the loop. Integer counter is equal to 1 while the counter is smaller than 1000. This is an example of the way the while loop works. Then we're going to go through, and we're going to test it, and we're going to print it out. We're going to test it, we're going to print it out. And then eventually we're not going to get anything. except for the computer might crash. So it isn't making any progress at all because we haven't changed the value of the counter. So the counter hasn't been incremented. This is a problem that most people will run into, and it's not what I would call sloppy. I would not even call it a programming error. I call it a logic thing. Like, you created a loop, but you didn't change the counter. The counter's always the same value. And it usually happens by accident. Nobody does this on purpose, so it's usually some weird logic where, oh, you know what, we're updating the wrong variable, and we're testing the wrong variable. Or we have a loop that just inherently just doesn't end, and you figure it out, oh, just rewrite the loop. So endless loops are a problem because you have a lockup, essentially. And usually the lockup is associated somehow with a loss of memory, going back to the concept of variables in C or C++. There's no garbage collection like we have in Java, so the memory is just going to fill up, and then your program is going to die eventually. So the problem is solved here. The integer counter is equal to 1, and we got counter plus plus down here. And so our counter is eventually going to be larger than 1,000 after 1,000 attempts through the loop. So I can skip through some of this here. Alright. If you want, you can download the slide set and go through it a lot faster on your own. Oops, do we have another problem here? Nope. Here's how it ends. It's going to come back with now true. So, if we want to test a condition similar to the while loop, but you want to execute it at least one time first, this one isn't going to do it. If the while comes out to false, you're never going to get one time through the loop. Sometimes you want to use the loop to test a condition. If the condition is true, then do something, because you may not know the condition ahead of time. That's what the do while is all about. So the do while you must execute at least one time, and the test is at the bottom. Similar format, except for we're adding a do at the front. Do something, and then while something is true, continue. If the while comes back false, at most you have one iteration through the loop. The while gives you no iterations through the loop if it evaluates to false. So that's your choice of getting it nothing or at least one time through the loop. And usually people end up with a problem with, like, we need to test a variable first. So then you'll see a bunch of workarounds for it. It's kind of interesting. I'll see an if then. I'll see something right before the loop that'll say, you know, if x is larger than 5, it's like that pre-test condition when all you had to do is do a do while. You probably could have done all that testing ahead of time, and then you would have run the loop. Otherwise, you would have just left it alone. So hopefully you're getting the impression there's ways of writing efficient code, and there's ways of writing spaghetti sloppy code. And not quite as clean cut as I would say in terms of some other languages. What are we looking at here? Oh, an example of the do while. So we have integer counters equal to 0, do counter plus plus, print out the counter. So we're printing out the 0 first. And then while the counter is less than 3. If we did this with a while, we would actually have different results. We would have one short.
After the condition, it will increment first.
Yeah. It's always going to do the do first.
Do then print.
Yeah, it's always going to print out. It's always going to print out 0 first. Yeah. If we did the while, it's going to increment it. 0 is going to turn into 1 first. So we'll get different results. Well, we'll be off by 1 essentially because it won't be doing the 1. So we can kind of see how the test works. Now we have 2. Now we have 3. Let's say counter's now 3. So to finish out the loop, it's still going to print the 3. Now it's going to go false, and the loop's going to end. So simple rules for the for loop. For is good for when you know how many times you're going to repeat it. While and do while are good for when you don't know how many times. All loops must finish, so otherwise they become an infinite loop, which is not really a good idea. All loops must have a test to continue, or they will become infinite loops. So that's usually a problem associated with it. All right, now we get to the more interesting stuff, functions and data passing. So we talked about pass by reference, pass by value, and function calls and referencing. I'm not going to cover pointers. I'm going to save that for a full lecture on its own. And that will come up actually quite soon. So terminology. Function. This is actually the theme of your first programming assignment. And I believe I have copied the assignments to my local disk. I don't have internet access. I put out there the source code for you. Right next to the assignment number 1, you'll see the body of the function that you'll have to write, which will be the date conversion. It asks you to take a date, like today's date. What is today? I'll just pick a date. 6/8/2011. You put that into the function, and it comes back with the day a week. This is Wednesday. So it should come back with, starting with Sunday is 0, 0, 1, 2, 3, up to Wednesday. It'll come out with a number. You have to use a case switch. So the program essentially that you're writing for the first assignment is your test to see if you've learned anything about C, or if you can take your Java skills and translate it to C, because you'll have to write a program in C, and the program will have you use iteration, it'll have you use a loop, it'll have you use a case switch, and it'll have you do a function call. If you could do the first program, you have the basic prerequisite to take and continue further with the object-oriented components of it, which is not a bad idea to actually do and not wait till the very last week of the term. If you do it now, then at least you know you have the skill set, and then you have a couple of days you can drop the class if you don't think you're going to be able to do it. The first program should be extremely easy, just like this material should hopefully be a review to some, hopefully. If it is your first course in C, hopefully you've taken a Java course or something like that, and then you can relate, you can transfer the knowledge. Otherwise, I don't recommend taking this course. It's not a C programming course. Okay. Although we haven't talked about it yet, we're getting there. I just want to cover the basics. All right, some terminology. What about a function is a logical grouping of statements, reusable chunks of code. You write it once, you call it many different times. The benefits, reusability essentially. Easy to work with at higher levels of abstraction, reduces complexity, reduces the size of the code. We write the function once, we call it over and over again. We don't have to worry about it. Also known as, and we saw this if you took the Java class, it's also a method. Functions are methods. Same thing with C++. Functions can be called in several different things depending upon the book or the concepts. Context, they're sometimes called procedures, sometimes called modules. Method, object-oriented programming calls them methods. It's really a function. And behavior, it could be behaviors. Member functions, that's why people like the word member functions. It sounds like a function versus a method. That's all the same thing. It's all the same concept. And it's something that we're calling, and we're sending it information, and we're running it, and it's doing something for us over and over again. So we have functions for many different reasons. In the traditional C, C++ environment before object-oriented programming came along, we did it for efficiency. In here, we've got repeated code all over the place, and it looks like spaghetti code. So we create a function. You can take all the code that's the same, put it in a function. You'll have to create a function for your first assignment, and then just call the function. And so what we've done is we've taken and we've created a function, and the function that we created is going to say cn number 1, cn number 2. It's an add function, or no, it does average. Average is equal to number 1 plus number 2 divided by 2. Simple average function. And now we're going to call the function myFunction in this particular example, and now we're going to call myFunction. So we're going to say here we've replaced the code and with just the keyword myFunction, which is the name of the function that we're calling. And we've put that in here. So please enter 2 numbers, and the person's going to enter 2 numbers. It's going to call myFunction, maybe send the 2 numbers to myFunction. So a lot of other code can be in there, but every time you want to use myFunction, you can have it available to you. In C or C++, I should say in C, that's the most common use of a function. In C++, it's similar to Java, where we write a function which would be a method inside of a body implementation, a class implementation. And we would call the member function from the instance of the object that was created from that class. So we would have functionality that we would use a dot notation with and say, my class name, my instance of my class dot my function, and we would call that code over and over again, and it gives us behavior, or it gives us functionality that's associated with the instances that we've created of these objects. So, and encapsulates behavior essentially. So what we have done is we've written code once and we've called it many different times. Same concept actually, and used in terms of the classes, because how many times are you going to try and assign names to employees? Write a function, write a method, says get name, set name, print name. It kind of automates the work for you. The more functions you have, the better, actually. There are some people that get carried away with this and they create an entire program of functions. You can do that. Concept being you want to do it for things you're going to call over and over again. So It doesn't make sense to have a function that calls a function that calls a function that calls a function that calls a function once for the entire program, and that's all it does. So that's kind of a waste. You could reduce the size of the code, hopefully, and makes it easier to comprehend, traces the code, skips all around, no longer linear, so you can have the ability to modularize and create the first abstraction, I guess, of procedures or modules. So functions actually became kind of the concept of jumping code. Remember the old days you had go-to statements? Anybody ever use a go-to? You know it is still supported in C. It's not part of Java. I don't know why. No, I do know why. It's legacy. It's only put in C because some people still have old legacy C code that used it, but in Java never uses go-to. Back when we had line numbers, it was really easy. You could say, go to line number 5, go to 6, go to 4, and that created iteration for us. It created flow control. It was like the if, then, else kind of thing. That was before we had real flow control. And now in C, we could say go to a label, and we put a label down the bottom. It's another way of doing a function is what it is, essentially. You've got to label my go-to or something. You called it something. Usually for error checking or, you're in the middle of something and you want the user to end the program completely because they're unauthorized. You could say go to exit part or something, and then you send them to the bottom of the code, and they go, oh, print this to the screen, and then the program ends. So it's used a lot for people who don't know try and catch. It's still used a lot for that. But I don't recommend using a go-to because it's going to be hopefully it's outdated enough so it's not in Visual C++ anymore. But it used to be. Let's talk about the scope of variables because this is a good rule to keep in mind. It's very similar to Java. The scope is what you can see. And what happens in a function stays in a function, you would think. This would be a pass-by copy, kind of an example. And I'll get into that in a few minutes. So the scope is what you can see and what you can't see. Variables that are defined within a function can only be seen inside of that function. So you need a way to send information to the function. You also need a way to send information back out of the function. This is referred to as the return value of the function. And the return value is the same as the type of function that you've created. You can't mix them. You can typecast them, but you can't mix them. So an example here we have function 1 can't see my int. That is part of function 2. So what happens inside of the function is kind of like Las Vegas. What happens in Vegas stays in Vegas. Did you guys see that movie Hangover 2? I didn't like it. The first one was better.
It's really gross.
It was not only was it really gross, but it was like a repeat of Hangover 1. It was exactly the same movie, just different, different location, but same movie. Like how many times? Hopefully, I'm not going to have a Hangover 3. But technically, and of course, that broke the rules because what happened in Vegas didn't stay in Vegas. It came back, followed him back. So, anyway, long story short, that's what's supposed to happen. So the procedure, all functions follow a procedure. The procedure has a return type, function name, and parameters. And the return type is an option. In fact, the type of function that you make gives it the return type. As I mentioned before, we had void main, and void meant there is no return type. You can have other void functions. I don't know why, but for several years, we had C programmers and we had makers of compilers that would not allow you to make main void. Like every function needed to be having a return. So we had this ridiculous integer main, and then on the bottom we had return 0 at the end of the program. And then now when C++ came around, they're like, well, what's wrong with void functions? Just like Java, if the function's printing something to the screen and returning, why should we bother with a return value? Not only does it waste memory, but it's unnecessary. So then the card's kind of turned around and the table tipped in the opposite direction. We go, okay, void's good again. So we have some legacy C compilers, and we have some people who grew up on C who were trained. Nothing is ever void. Then we have the newer generation that says, you can make it void. Why not? It's supposed to be void. So technically, void's not a bad word. It's a good word. All right. So if a function doesn't return a value, it's supposed to be void. You don't just return 0 for the heck of it. Otherwise, the return type is the data type that you're going to be returning. So if you're going to return a character, then you have to have a character function. So you have an integer, character, Boolean. These are all different return types that can be used. In terms of figuring out the return type, we have the function name. So we have like average. It's probably going to be a double or float. You know, get letter grade. It's going to be a character. Are you asleep? It's going to be a Boolean, yes or no. If you're asleep, you're probably not going to answer it. Who knows? Get GPA is a double or a float. Print menu is going to be a void because you're just printing something to the screen. So don't confuse the function that does with it what it does with what its return type is, because it depends on what you're going to return. So a lot of people, especially a lot of new people, get hung up with what return type should this be. And what ends up happening is they find one that works and they use it for all the functions. And it's like, wow, everything you have in your program is an integer. How does that work? It's because they don't really understand that data type that they're using for the function is the type that they're returning from the function. So, and if they're not returning anything, it should be void to begin with. And if it's integer, then didn't you see typecasting from a double to an integer in the bottom so that the function works correctly? Then they could just make the function a double and not have to do any typecasting or anything. Or make it what it's supposed to be. Alright, the function name can be anything. It follows the same naming conventions as variables, similar to names of variables. Can't be almost anything except a reserved word, can't start with a number, and can't contain special symbols, except for the underscore and the $sign. Same rules as variables. Same rules as Java, actually. It should begin with a lowercase, normally. So hopefully we put function, we don't have to. But it's the standard, I should say best practice, to put function names with a lowercase. Method names too, with a lowercase. Class names with an uppercase, which is interesting. That way you can quickly tell if you're looking at a class or a function within the class. But I'll talk about that more when we start writing classes. If multiple words in a function, you have to capitalize the first letter, and then each word except the first character is in lowercase. So here's an example. In fact, this is pretty good naming conventions, widely accepted these days. Not a rule, just a best practice. This is an example where we have capital A, capital E, capital I, because we have new words. Because we can't put spaces in there. So you'll see this used a lot, actually. There's a word for it, and I can't remember what it's called. It's called something. There's a naming convention it's supposed to be called, and I can't remember what it is. Let's talk about parameters for a few minutes, because this is what causes the most confusion in terms of people who haven't written functions in a while. You can't see other people's variables. What happens in Vegas stays in Vegas. So we have to send information to Vegas if we want to we have to pack our bags and bring it with us because we don't have our clothes there. So we have this thing called scope that happens inside of the function. So special variables are used to catch the data, and they're being passed to the function. So this is the only way that a main algorithm or a function can communicate back and forth, is to send the information. And it's referred to as passing. And as I mentioned before, we have two different passing methods. We can pass by a value, or we can pass by a reference. Most of the time, you pass by value. And sometimes when you pass by value, you're actually passing by reference, but you don't know it. It's a side effect. This is one of the problems with C++. Was fixed in Java, but C and C++ still has a problem. Let's talk about arrays for a second, for those people who are familiar with the concept. Every time you send an array, and you actually send the array to a function, it gets passed by reference, even though you're passing it by value. And if you don't know what the differences are, think of the value as a variable. And when we pass a value, if I said integer I out in main, and I said send I to this function, that would be passed by value. And when I send I, we're going to get whatever I actually contains, whatever I've assigned it, which maybe I've assigned it to the number 5. We're sending the number 5 as I to the function. When I say pass by reference, the reference is a memory location. And unfortunately, arrays in C++ are implemented in the form of addresses, address spaces. And actually, Java fixed the problem because everything's passed by reference. There's no more passed by value anymore. So in terms of what it is you're doing, you're passing a memory address. When you pass a memory address to a function, and the function manipulates the data that's at that memory address. When the function ends, the data is changed permanently. So what happened in Vegas came back. It's following the program back, and the changes are permanent. They're not temporary. So I'll see some examples of that. We'll see a lot of examples of this as we look at classes, because when we work with reference variables with classes, we actually have to do our own garbage collection. So for those of you who want a preview of some of the first topics we'll be talking about, in Java we had the constructor. That was a member, as a function in a class that built things up ahead of time and initialized variables. In C++, we have the constructor and the deconstructor and the copy constructor. We actually have more work. Same concept, but the copy constructor makes a copy of referenced variables, aka pointers, that I'll talk about before I even get into any of this stuff. And the pointers are memory addresses. So when you send a pointer, just like a regular other variable, to a function, you're actually changing, it's passed by reference, and you're changing what's at that memory address. When you're using that inside of a class implementation, you have the same side effect as you're having a function. You're changing the memory. So what if you don't want to change it? You can turn it into a copy. And that's what the copy constructor is going to be about, where we make a copy of that referenced information. We send that copy over to be processed, and we come back with a copy. It's like making a photocopy and then playing around with the photocopy. You never touch the original. So we have copy constructors. We also have this thing called a destructor, because when we start referencing memory locations, which we can't do, there are no pointers in Java, which is why I'm going to cover pointers in this class. Because some of you guys know Java, but none of you, if you know Java, you can learn C pretty easily. But you've never seen pointers before. Because pointers don't exist in Java. And pointers become a problem when you start working with object orientation and classes. Because we have this thing called a destructor that takes and has to remove all allocated memory that you've allocated by the class. If you don't do that, you end up running out of memory, because C++ doesn't have garbage collection either. So we do have to follow through and kind of do some pointer stuff first and get through a few things before we can hit classes, actually. Anyway, let's get back to parameters for a second. I'm on a little slight tangent. So the only way to get information is into a function is to send it with a parameter. This is the same thing true for methods. If you're familiar with Java, we sent, my object dot get name, or no, set name, and we sent it a string for a name or something. So we're going to use that information inside of the function. So if no parameters are needed, then you leave the parentheses blank or empty, and you don't actually specify any parameters. And here's some examples. Remembering that the procedure is performed inside of the function. What can you tell me about each one of these functions? Well, void do something integer data is taking on an integer value, and it's not returning anything at all. Double average integer 1 and integer 2 is actually taking two integers. And this is the interesting thing that most people who, it's the same true for Java, but people are afraid to do that. Your return type can be different than your parameter types. And if you keep that in mind, if you look at the second example, you're taking an integer and then another integer and kind of coming up with the average. Most likely you're going to have a half. You're not going to have a whole number. So you're going to return a double. And that's correct. So the parameter types don't have to be the same as the return type or the type of the function. And then here we have Boolean, did he pass? It's going to come back with a true or false, but it's not taking on any parameters at all. It's just doing an evaluation. Character is what was his grade. It's going to come back with a letter grade. Character. Void scare student. So character, grade of student. You're going to send it a character. It's not going to come back with anything at all. Instead, it's probably going to print something to the screen that says, you failed, you failed, you failed, 100 times or something, using a loop of some sort. Alright, so you can get the function to work for you. You can call it by name, pass it the right stuff, hopefully, pass the right number of parameters, hopefully, and if it expects two things, pass it two things. This is the problem people have actually when writing classes, is they write these functions inside of the classes, and then they forget, oh, it takes on two parameters, oh, it takes on one, and then they end up writing multiple functions to fix their problems. And then they figure out, oh, I got twice as much code in here than I really needed, because each time I'm using this function, I'm sending it different parameter lists. which can be done for certain reasons. However, in practice, that would be a waste. It would be very inefficient if you were doing it for the reasons I just mentioned. Usually you would have varying numbers of parameters to indicate some sort of polymorphism, perhaps, or some sort of a constructor behavior or something that was desirable outside of inefficiency. So you pass it the right number of parameters. If it expects the characters, don't pass it a double, and the parameters must also match identically in order. Same case as in Java. You know, if it's an integer and a float, send it an integer and a float, not a float and an integer. So return something, do something with it. Interesting. A lot of people write functions that return values and they don't do anything with it. And I'm thinking, why not? Why are you returning a value? If you're going to return something, do something with it. If you're not going to do something with it, don't return it. Why? Because it's a waste of memory. We actually have to think about memory in C++ and in C. Not like Java, it doesn't clean up for us, which is one of the reasons why people like Java. Built-in garbage collection. If we return something, don't worry about it. It just gets thrown away. The garbage collector will come by and pick it up. If you're writing a C program that works on an embedded system that it only has 1 megabyte of RAM, and you've used it, and you've returned a value, it's very easy to run out with 1 megabyte or less of RAM on that system. Yeah, it's important. If you return a value and you didn't use it, don't return it. So, because it wastes your memory, it uses up all your resources. So it always starts at main, so we have our main function, and we're going to call the function twice. So here we're going to result. We're going to make, and this is a standard convention for those people who are not current with programming, have been a while. It's very common to put it all into one statement to say, instead of running average number 1, number 2, which you can run on its own, we're going to take and say the result is going to be equal to average. This result number 2 is going to be equal to the second function call. And then out here in the average, when we pass number 1 and number 2, number 3 and number 1 to this function, and the function is going to be double average, and then it's going to return a value. So the average is currently inactive until we call it. When we call it, we're actually taking and reserving the memory for it. And then we're substituting values in, and then we're returning those. So as we follow through the source code here, the function kind of wakes up, loads it, puts the stuff in there, runs it, and then sends it back. Why do you need to know that? Going back to my embedded systems, in fact, there's a lot of C. In fact, it's UC Linux, mostly with C programming that's done in embedded systems, where you might have 1,500, 2,000 functions maybe. You might have a lot of functions. It's nice to know that it doesn't activate, doesn't actually get loaded until it's run. And you want that function call to end. You don't want it to hang. Because we have these things called activation records in a runtime stack. If you know anything about operating systems, anything about Linux or running runtime engines, there's only a certain number of activation records. And every time you call the function, it opens up a new set, puts it on the stack, and you've populated it out with information. Your runtime environment can actually can actually freeze up on you because you've run out of space in terms of the runtime environment. Because what we have that's different with C++ than with Java, if you took the Java course, the Java runs in a JVM. Not bad, controlled by the Java people. They set the stage for everything. C++ runs in the runtime environment of the host operating system. So if it's a Windows system, you're writing that compiled code is working with the host. It's working with the Windows operating system, Windows runtime environment, which is using activation records, or it's working in a Linux environment that's using the same similar concept of a runtime engine. And the code actually has to be optimized to work with the runtime engine. Classic example, have you guys heard of recursive functions as an example? You can write a recursive function in C++ that's going to hose your system. You can write one in Java that's not going to do anything at all. So a recursive function is a function that calls itself, and then it calls itself, and then it calls itself. Classic problem with that is it opens up, it goes back, now this one's asleep, it goes back, loads items onto activation records and populates out a stack in the runtime environment, and then it doesn't ever end. The function never returns. Instead, it just calls itself again, And then you get runtime errors or overflow, Stack Overflow errors, and all sorts of these different unique Windows error messages that come out. Sometimes it's memory overflow, Stack Overflow, or runtime, something related to runtime. You know you've exceeded your allowable activation record space, which you'll never get with Java. You will never get that error message with Java. So, different activation system. It doesn't use a runtime stack. Alright, so the function wakes up, passes the information to it, does its stuff, it returns a value, the stuff goes away, then the function goes back to sleep, and everything gets erased out of the runtime environment. We actually have to look at this only because we don't have automatic garbage collection. We actually have to think about runtime environments, we have to think about wasted memory, stuff like that. So another quick example here, the return void return type, where we're sending it number 1, 2, 3. Actually, we're just sending it number 1, it looks like. We're declaring variables, initializing the variable. We're waking up the function. We're sending it print number 1. Oop, the number goes in there. 5 enters in there. 5 gets used inside of the function. And then we're printing it out to the screen. And we have the output of 5 that goes onto the screen. And then the function's done. With void, it just goes away automatically. So we don't have to worry about a return value that comes back. It just automatically disappears. Yeah?
So default return type for a function is int or void?
There is no default return type for a function, which is interesting. It depends on whether or not you plan to return something from the function. If you're not going to return anything at all, then the recommendation is to make it void, because then you don't have that extra memory taken by the return value. If you are going to return something, then you have to think, well, what am I going to return? And you want to avoid typecasting, as I mentioned before, which means you don't want to make everything integer and then typecast it to floats or doubles or something, because you're going to lose precision. So if it's going to be a double, make the function type a double, so it returns a double. And then you're using a double and you don't have to typecast it. You want to avoid typecasting it in all cases, because it's very inefficient. So here's some function rules. You can't define a function inside of another function. Doesn't work. Not in this language. You can in other languages. Function programming languages you can. Functions usually reside inside of a class. In modern day C++, we're creating these functions inside of classes. Unlike Java, we can have a function outside of a class. The rules for Java, functions are inside their methods. Everything's a class. We never not have a class. If you think about it. C++, we can have functions without having classes. And there's no requirement to have a class. We can use a function anytime we want. In fact, you're going to do it in the first assignment that you're writing. We also have this concept of a prototype. We have prototypes in Java, but nobody ever uses them. I shouldn't say that. They're used for different purposes, the prototypes. But the prototype in C++, the only purpose of it is for the compiler to check the function use before the function's declared. Because what ends up happening in C++, which is different than Java, is we truly have, in C++, we truly have a line-by-line execution. The execution of that program starts at the very top, and it goes to the very end. If we've used a function before we have defined the function in that particular code, what function? What are you talking about? The compiler has no idea. The program has no idea the function exists. So we put prototypes at the front to say, we're going to use this function, and we're going to use that function. And then after, way down at the bottom, we put our function declarations. Cleans the code up a little bit. You know, makes it easier to use. Makes it easier to read sometimes. Or we don't do the prototypes, and we put all the function bodies up front. So one of the tests of that first program is, where are you going to put your function? Are you going to put it before main? Are you going to put it after main? And then it doesn't belong inside of main. Main's a function. You can't put a function inside of a function. So half of you who are brand new to C are going to put that function inside of main. Half of you are going to put the function at the end, but forget the prototype. Put it at the end, and forget the prototype, and the function won't run. And then some of you will actually kind of figure it out, put a prototype in, but you'll use the wrong prototype and the wrong syntax for the prototype. And then after that, you'll figure out, oh, we'll just put the body of the function up there instead of the prototype. And then you'll figure it out, hopefully. I don't know. It's kind of the test to see if you actually are familiar with C versus Java. Because you don't have any of these problems with Java. you'll never run into any of these situations with Java. So, which is kind of interesting. Anyway, so use a prototype. Functions can't see each other's variables either. Unlike Java, there's no global anything. You can't see anything. You can't use anything. You actually have to tell it where it's at, what you're going to use, what you're going to see. So here's a prototype. This is what the function prototype looks like. So we put this down here. We have void print number on the bottom. And in here we've used print number. Without this line right here, we're going to get an error message that says print number unrecognizable or error. It doesn't exist. So the prototype is nothing more than the first line with a semicolon at the end because it is a line of code. It's not a function declaration. So some people will leave out the semicolon, or they'll put in the opening and the closing brackets, and they've essentially defined a function. So down here they're going to get a redefinition error message. Function already defined. Because what we've learned from Java is we can put opening and closing brackets in there, and then we can define it later. Which doesn't work the same way. So here, this is the function prototype. This saying we're going to have a function that's going to be called print number, and it's going to take in one parameter, my number. And so then down here we can go back and we can define the function. So one of the things you'll probably end up running into, maybe not. Now that if you're sitting here listening to me, you probably haven't. So let's talk about your first programming assignment, because this is where this comes into play now. So I want to talk about the first, and I think I've downloaded it. I hope, because I don't have internet access. So you're going to complete the programming problem on page 4, chapter 8. You don't have the book, don't worry about it. I've reduplicated the assignment for you in the assignment description. I've cut and pasted the description. You don't need the book. If you're brand new to C or C++, and you've never programmed in Java, get the book. I highly recommend the book, actually. It's an excellent source, and it's out in many different versions, and you could probably find it for $5, perhaps. It's the best investment you'll ever make. An additional requirement for this program is you're only going to use C in and C out in terms of the I/O. I don't want you to use printf or scanf because some of you are C programmers and I need to get you into C++. So C in and C out or C++ from iostream.h. Printf, scanf, that's stdio, that's C, that's not C++. And you must create at least one other function outside of main, because I know I have some students who say, I created a function, it's called main. Nope. 2 functions, main and another function is what you want to create. And I hope that I have this assignment here, actually. Oops. Don't save. That's actually the end of the boot camp, by the way. Yep, here it is. Programming assignment number 1. I'll talk about the interface a little bit. This is your challenge. This is your test, your self-test. It also counts as one of your assignments for the course, which is great. It's a freebie. The object is designed to get you back in the swing of things, and the main purpose is to write a function. Actually, let me see if I've got access. Good. Let's see if I could just get in far enough. Oh, good. I've got access. Going as fast as I can to make sure. Oh, there it is. Look at it. Here we go. Look at that. Okay, here's what I've done for you. This is different from what I told you last week. Or, excuse me, this is what I told you last week, but I hadn't done yet. Now I've done it. The program. The theme of the program, and here it is, the theme right here. It's not a math class. I'm not going to have you calculate anything else. Instead, what I've done is I've given you 2 files with 2 different techniques. While I still have the access, I'll go through the files first. One of them is called DOW, Day of Week.c++. This is the new stuff. The other one is called Day of Week 2.c++. They're both underneath the assignment 1 link. This is an easier one, but it's not as correct. The accuracy of your program doesn't matter. When you run this code, in fact, what you can do is test your compiler with this code, either one of the versions. They should compile just fine. It's going to spit out a 0, a 1, a 2, a 3, hopefully 0 through 6, because there's 7 days in a week. 0, I believe, is Sunday, Monday, Tuesday. I might start with Monday. You could test it with today's date and figure out which day Wednesday is, and then you can figure out what your return value is. You're going to write a program, and you're going to take what's inside a main here and put it in a function. So you're going to have a main function in your program, just like hello world, that's going to call a function that's going to return an integer value. So your day of week function is going to be integer, probably. And what's it going to take? It's going to take a date, maybe. So maybe it's going to take a numbered date that's a Boolean date. And so you're going to have to figure out, well, some of the stuff up here gives you a Boolean date. And then the Boolean date is used in a calculation. So you have to decipher what the code is doing, send the function something that you'd like to convert it, return, usually probably an integer is going to be the easiest, the day of the week. And then out in main, print out, case, switch this number, case 0, 1, 2, 3, 4, or default. The default might say bad date. 0 might say Sunday, Tuesday, Wednesday. So the interface is the program can ask the user, or you can use it from the command line and say, my program space 6/8/2011, and it'll work. One of them actually takes a leap year into consideration too. It comes back, and it'll say, the day of the week is Wednesday. That's all your program is doing. It's taking a date and it's converting it and telling you what day of the week it is. Any date. And whether it comes out with the right date or the wrong date doesn't matter. Because I haven't tested these lately. One of them has an error in it. You might be able to fix the error. That might be a challenge for you. What you're grading on is, number one, do you have two functions, a main function and a separate function? Are you calling the separate function, and are you passing the separate function some information? And are you returning a value from the function and using it back out in main somehow? That's the grading criteria for it. You need to know how to do all that to work with classes in C++, because classes are nothing more than function calls. And then once we worried about function calls, we have to actually know about passing information, because we have to work with pass by value and pass by reference and stuff like that. And don't worry about arrays at this point, because I'm going to start in with arrays next week, I believe. So I still have a couple more weeks of C++ basics before we get into creating the classes. I want to talk about arrays, and I'm going to talk about pointers after that, and then we're going to hit classes. The interesting thing about creating a class in C++, it's the same as Java, except those different constructors and the concepts of how pointers are used and how memory is organized and stuff like that. And then, the passing is a little bit different, because we have more control over the passing to parameters in C++ than we do in Java. So. But that's pretty much going to be the flow for the next couple of weeks. So if you're watching the video and judging whether or not you want to show up in person, or if you're here and you want to know what's going to happen next week, we're done with the boot camp. We're going to hit, I think, arrays next probably, and then I could take a look at the lecture. But the timing is you should do assignment number 1, like now. That way you know whether or not you want to take the course. If you can't do assignment number 1, if assignment number 1 is too hard for you, you're in the wrong class. So, questions? No? That was really quick. I got through in 2 class meetings. Sometimes it takes me 3, because sometimes I get students who ask questions. And then I got to slow down. And I got to give more examples. But this was really quick. You guys are smart. If we don't have any questions, did you? No.
We are using namespace.
Oh, we're doing, namespace I'll actually talk about next week. I talked about it last week. Were you here last week? If you watch the video, you'll see a little namespace, but next week I'm going to have source code examples, and it will be using namespace. The concept of it is you're setting a different environment space. It's, again, different from Java, because Java is, distributed. There's no environment. The JVM controls the environment. In C++, we control the environment ourselves using namespaces. And let's say, for example, we have 2 libraries that we're using. One is a third-party library, and one's a built-in. Let's say it's a new iostream.h, because we have a LCD display we want to read and write to or something. And we might have a C in and a C out that's associated with the standard I/O. We might have C in and C out that's associated with hpio.h, iostream.h or something. We can load different namespaces, put libraries in different namespaces, and switch between the namespaces, and then we get the correct C in and C out of which namespace we're in. Think of it more like a global space or environment change. Standard, if you're using dev C++, it requires you put using namespace standard or std. If you load in and create a default project, you'll see the template. Just follow that template. And just say, or if you load up one of the sample files, I believe it comes with a couple like hello world files or something. Or if you watched the video from last week, I loaded up a hello world and ran it, compiled it in dev C++. You'll see the standard and just cut and paste that. The other thing with C++ is you actually have to create, if you're using dev, you have to create a project. If you try to compile without the project, it's not going to compile correctly. The compiler won't run, but so just create a default project and use it for everything. Good question. Well, watch the video. The first video, you'll see namespace being used. Any other questions?
So exit, if we use an exit in a function, so it exits a function.
The whole program will end. Exit is, believe it or not, a system call, which is different. Actually, it's implemented in Java as a system. It's a fake system call in Java. C is used, the real C is used as a system programming language. Exit is actually a Unix system call that says close down, shut down, end the process.
We also use exit of 0 and exit of 1.
Yeah, when you're sending exit a status, if you send exit, it's a function actually, it takes an integer value. So you can say exit 0, exit 1, and you're sending it as a function call. And you can say, you could and basically indicate, if you send it to 0, it could be exit OK. And then exit 1 might be exit because we are confused. We don't know what's going on. And then you can use that because if you think about it, somebody called that function, that exit. So that return value, believe it or not, comes back into the environment space and gets returned to the calling process. So if it's a 0, you could say, hey, I think you should shut down your system right now. Or if it's a 1 or something like that. You could use the status of that return value to determine what should happen next in terms of the processing. They implemented that actually in Java. You can actually use an exit, I believe, yeah, in Java. It came from C, actually.
But I don't know the difference actually. Exit 0 and exit 1.
The difference is whatever you use it for, it's a return value. That value, the 0 or 1, is coming back to the calling process. And you can use it to, figure out what happened as troubleshooting or something, debugging. If you wanted to exit the function, you'd use the word break. Break is going to take you out of that function and bring it back to main. So break is actually used a lot in functions that don't work correctly. Like there's a problem, you put break in there. When all else fails, break, go back, and you return without returning, you just break. Any other good questions? Those are excellent questions, by the way. No? All right, see you next week then. So we'll moving at a slightly faster pace next week. So for those of you who are really bored, maybe we'll hit something new. Okay, see you next week.